Hello everyone, I'm Eric, the evangelist of the Cocos engine department. In order to make your game package small enough, we split the original Cocos engine. Only the functionalities that are necessary for game development were left in the engine, and the rest were made into extension modules, which can be imported when your game needs it. And we have a built-in extension store in Cocos Creator. Check it out. Click on the extension menu, then select Store. Here you can find Creator extension. Since I chose the version 3.0.0 of the engine, the extensions we see here only support version 3.0.0. We can also switch to the Chinese version. You can see that there are more extensions in the Chinese version. You can also go to our official website, which contains all the extensions corresponding to the different versions of the engine. You know, the main purpose of this extension store is to give developers a more convenient place to browse, download, and install extensions. And now, in order to enrich our extensions to meet the various needs of your developers for making games, we made this tutorial to help you write the extensions you want. We also encourage all developers to submit their own extensions, artwork, music, and sound effects to our extension store and share them with other developers. And of course, you can also sell them. Before writing extensions, let's take a look at the base structure of Cocos Creator extensions. Cocos Creator is based on the kernel of Electron, which is certainly not new to you, because it's an open source framework on GitHub, just like VS Code, which is developed based on Electron. In fact, Electron can be equivalent to the collection of Chromium, Node.js, and native API. We can just think of Electron as using an external page as a GUI, controlled with JavaScript, and the stripped-down version of the Chromium browser. It allows developers to take advantage of a powerful external ecosystem to develop pages without considering compatibility. And Electron itself is actually a third-party project for Node.js. It allows developers to use a large number of open-source NPM packages to meet their development needs. It also gives Electron the ability to perform underlying operations, such as reading and writing files, and even some operations with C++ integration. And the native API provides Electron with a native ability to create cross-platform desktop applications. For example, it has unified native interfaces, windows, trays, and so on. To write extensions, you need to understand the three main front-end languages, namely HTML, CSS, and JavaScript. You can think of HTML as the skeletal structure of a house, that is the framework and layout, including graphics and video, which are also the basic elements that make up a web page. The CSS is actually the appearance of the house, that is the effect or the presentation. For example, the colors and the fonts of the text and animations. And some functional and substantive work has to be left to JavaScript, such as the interaction between the user and the web page. These are the basic skills that a front-end web developer needs to master. You just need to go through some simple tutorials, then basically you can complete some of the functionalities needed for extension. Once the page is complete, data interaction between the extensions is required. As you know, Cocos Creator 3.0 has a number of processes that run independently. These processes need to interact with each other using messages. Our messaging system here is inter-process communication, and we have extended and encapsulated it. The message interaction is generally needed in two situations. One is peer-to-peer messaging, that is, actively sending a message to others. For example, Querying the number of nodes of an object is a peer-to-peer message. The other one is the broadcast message. When the process completes an operation, it needs to send a notification to everyone that the operation has completed. For example, if a scene is opened, the other processes related to the scene need to be told that the scene is ready and everyone can start working, which is a broadcast message. Next, let's take a look at how to use extensions in practice. First, click Extension in the menu bar at the top of the editor and select Extension Manager. Here we can see that there are three types of extensions: internal, project, and global. The ones in internal are official extensions, while we can see that project and global are empty. These two are actually the extensions that developers download or write. Since I haven't downloaded or written any extensions right now, they are empty. And the difference between project and global is that the scope of the extension is different. The extensions in project are only used in your current project, while the extensions in global can be used in all projects opened with Cocos Creator. Another difference between them is that the storage paths are different. Now let me create a project extension first. Then open the extension manager. You'll see something appears in project. You can find the directory of the extension by clicking on Open Folder. You will find it in the extensions folder of the project. Now let me create a global extension. Again, go to the Extension Manager panel and open Global. You can see that there is an extensions folder in the root directory of Cocos Creator. The global extension is in this directory. Note that the extensions folder doesn't exist from the beginning. It will only be created when you have already installed extensions inside Cocos Creator. So if you haven't, but you download an extension from the internet, you need to create an extensions folder under the corresponding directory according to your needs, and then put your extension under this folder. Let's take a look at the directory structure of an extension. We can see that it's a folder that contains a browser.js and a package.json. So what are these two files for? Package.json is a description file. It describes the purpose of the extension, which allows Cocos Creator to know exactly what the extension does. And browser.js is an entry file that will be loaded during the launch of Cocos Creator. Let's take a look at its contents. Name is the name of the extension. Package version is the version number of the extension system, currently fixed at 2. Version is the version number of your extension. It is recommended to use Semver to manage your package version. Description is a description of this extension. Author is literally what it means. Main is the entry file. Here you can see that browser.js is already filled in automatically. We can find the descriptions in the extension manager that correspond to the one in package.json. You can see that all the descriptions are exactly the same as the one shown on the panel. Here I type replace material after name and then fill in a random author. Then refresh the panel. You can see that the description has been changed along with package.json. Note that if the package file is modified, you need to click refresh to see the effect. Then we change the name of the extension folder to the same as the extension. Note that your extension shouldn't have the same name as the built-in extensions in internal, or they will replace the original one. So we need to ensure the global uniqueness of the extension name, unless you do want to rewrite the functionality to replace the original extension. If you want to upload your extension to Cocos Store, there are some restrictions on the package name, which can be found in the official documentation. These are the basic fields automatically created by the editor, and each extension is a complete functional module that requires UI interaction. So here, we need panels. To define the detail of the panel. Then we need contributions. To extend the functionalities provided by the editor. Currently, contributions is only available in internal functionalities in Cocos Creator. And in the future, we will provide the ability to use contributions between extensions. That's all for the description file. Next, let's take a look at the entry file. Methods can be defined here, which will serve as the interface to the operation. The function after load is executed when the extension is started, and the function after unload is executed when the extension is closed. Next, let me start to write an extension. I'm going to make an extension that can replace materials. First, we need a portal to this extension, just like these menus on the menu bar of the editor. So, we need to define an array named menu in package.json under contributions. And we use a key called path to define where to open this extension. Then we use label to define the name of this extension in the menu. Both of the keys support internationalization, which means it allows to display the corresponding interface according to different languages and regions without modifying the internal code. If we want to put this extension inside the extension menu, we can just write it in internationalization format. If you want to give multilingual support to label, you need to create a new folder in your extension folder and name it I18N. Then just name the two JS files according to the abbreviation of the language. To save time, I wrote the two JS files in advance and copy them into the I18N folder. Let's take a look at what's in these two JS files. I've written the name of this extension to be displayed on the menu. These are the two different ways of writing, but in the JSON file they are used the same way. The first part is still I18N. The second part is the name of the extension. Then, the title in the JS file. Okay, let's see if this multi-language switch works. Let me refresh it. Now, you can find your extension in the extension menu. Then let me switch the language. As you can see, the name of the extension has also changed with the language environment. Let me change the language back. The name of the extension changed back as well. These two keys are required to be added. You can also design the extension icon if you like. Now that we have the button to open the extension, but how is the extension going to respond to the execution event when the button is pressed? Here we can use message. Since we're performing the operation of opening the extension panel, we give the message the name Open Panel. Then how do we notify the editor of this message? Now it's time to use the messaging system we talked about before. We need to define and use this message in contributions. First, let me define a messages. The name must correspond to the name of the message above. Let me define a public property for this message, which indicates whether the message is displayed to the public or not. We set it to true. The message can also have keys like description and doc to show more information about it. Then we need a methods array, which is used to define the queue of methods for which the message is sent. It's actually the callback function that is executed after the message is received. Let's name it Open Panel. So where is the definition of this callback function? It's actually in our entry file. The method in browser.js is where the callback function is written. Okay, let me write the function that opens the panel in. Here, I use console log. To see if the message went through. Refresh. We can see receive message here, which means that the message communication is complete. In other words, we can open the panel with this message. Next, we can edit the panel. As I said before, we can define the data of the panel through panels. We can use title to define the name of this panel. Just use the title defined in label before, because it also supports internationalization. Next, let's open the official documentation to see the other specific properties of the panel, which is in extension panel of extending the editor. These are the configuration information of the panel. In addition to the title, you can also customize the panel's icon. Type is used to set whether this panel can be docked on other panels. Dockable means yes, while simple means no. Also, you can limit the size of the panel under panel size. The resizable under panel flags is used to set whether the panel can be scaled or not. The save here is used to save the data. For example, we open the extension panel in the editor and then close the editor. By the time we open the editor again, if the value of save is true, then the extension panel will be opened at the same time. If the value of save is false, the next time we open the editor, the extension panel will not be opened automatically. Main is used to define the panel's entry file. This entry file is used to implement the specific logical functions and styles of the panel. Note that all of these with question marks are optional. Even if you don't write anything, there will be a default value. Okay, next let me write the entry file. An extension can have multiple panels, so we need to give them a name. Let's define it as the main panel. Then put the title in it. Then we use main to define the path to the entry file. To make the directory look more concise, we can create a new folder in the extensions directory and name it panel. Then create a new JS file and put it in the panel folder and name it panel as well. Add useDirect first. Since this extension is used to replace materials, we first need a place to drag and drop materials. Let's start by template. Here we use multiple lines, and template is HTML text supported. Some of you may not know how to write it. In fact, in the developer menu, select UI component. Here, you can see a lot of common APIs encapsulated by the editor. For example, this is the asset we need, along with the button and color. What we need is to get the asset, so we can just copy the code below. And to get the material, we can use the DevTool. In the developer menu, select Open Scene DevTools. Enter CC dot. Then you can see all the modules of the CC class. Let's look for the material we need. Got it. Copy it and paste here. This value corresponds to a UUID. The UUID is used by Cocos Creator to manage game assets. It will assign a unique ID to each file. We don't need the default material here, so we can just delete it. Next, we need a button to confirm the action of replacing the material. Find UI component in the developer menu. Select UI button and copy the code. Change the name. Just 2 simple lines of code define all the elements we need. If you want to open the panel, you can call it inside the callback function in browser.js. So how to write the code to open it? Again, in the developer menu, select Open Scene DevTools. Enter Editor. These are the external interfaces provided by the editor. Find Panel first. Then find Open. This is the function used to open the panel. Then enter Editor Panel open. You need to pass it a parameter, because as I said before, an extension can have more than one panel, so we need to tell the editor which panel to open. It's written in the format of the extension name plus the name of the panel we want to open. The panel name can be omitted in one case. See, I've already named it as main panel, but if its name is default, it means that this panel is the one I want to open by default. So you can delete this last part of the panel name and enter the path to the panel's entry file. Let's see if it works. Refresh the extension first. Okay, we have opened this extension panel. We can also open it with shortcut keys. The section about shortcuts is also in contributions. There is an array called shortcuts. This array can define multiple shortcuts. Here we use message to bind the shortcut messages, which is open panel, the message we use to open the panel. The shortcut keys are different for different operating systems, so we use Win for Windows and Mac for Mac OS. Since my computer is a MacBook, I use Mac to define the shortcut keys. Define it as Command+I. Let's see if it works. Again, refresh the extension, then press Command+I. As you can see, the extension panel has been opened, which means the functionality of opening the extension panel with shortcut keys has been implemented. We can see that the layout of this panel is a bit ugly, so we can customize it with style. Style supports CSS format. Here we have asset and button. Let's first set the box where we want to place the material. UI asset. Then add margins to it. Set the top margin to 15. It also supports the percentage format. Set the right margin to 5%. Set the lower margin to 5 and the left margin to 5% as well. Since the left margin and right margin are both 5%, we set its width to 90% so that it can be spread out horizontally. Next, set the layout of the button. Set the top margin to 5. Set the right margin to 5% as well. Let's see the result. Okay, it's done. The template and style can be used not only in the form of strings, as described above, but also by importing external files. Template reads HTML files, while style reads CSS files. The layout of this extension is relatively simple. If the layout is complex, this part can be split out as a separate file. Let's write the logical part of the extension. If you want to replace the previous material, you should first get a new material that you dragged here. So we need an element selector, which is the $sign. This is an HTML element selector that calls query selector directly to find elements. Here we need to get material, because UI asset is a public label. So let's redefine a class over here. Mat. Since there is only one button here, it can be used directly. Just use the UI button label directly. Okay, all needed elements are ready. So at what timing do we need to get a new material? That's when you click on this button and are ready to replace the material. So we need to add an event listener to this button. This listener needs to be registered in the ready function of the panel. Again, we get this button through the element selector. Then add event listener to it. And what is this event that is listened to? We can select UI button in UI component. Here you can see events. Confirm is the event we need. We need to get the material in this event. Again, the material is obtained through the element selector. Determine if the material exists. If the material exists, we can notify the editor to perform the replacement operation. Then we need to send a message. The parameters here are, in order, the name of the extension and the name of the message to execute the replacement. Let's go to browser.js and define it. If we want to perform a replacement operation, we need to get a new material. So here we need to pass a parameter of the material. I'll refine this function for the replacement operation later. Now the name of the message is ready. Then we need to pass it the parameter of the new material. Then we go on to add the logic of replace. To replace a material, first get the object that needs to replace the material, then get its mesh renderer. But note that Cocos Creator gets the relevant asset data from the UUID. So at this point, we also need to change the UUID of this object reference material. Since I've already written this function, I'll just copy it over. Let me briefly explain this function. First, we'll get the type we selected by using getLastSelectedType. The type may be asset or node. If it's not node, we just return it. If the type is node, we just use the type to get the UUID of this node. Then we get all the data of this node by message request. And that's all its info. Then we get all its components and iterate through them. If the type of the component is mesh renderer, then go ahead to assign the UUID and the path of the node's material. This is the UUID of our object. With this function, we have finished replacing the material of the object. Since we use await here, we change replace to an asynchronous function. Generally, messages are used with asynchronous functions. Again, we change ready to an asynchronous function. We also need to register replace in package.json. Because all messages are required to be registered. Save it, and let's see if our replacement function works. Let me create a cube. Then open Replace Material and drag it over here. Replace a material. Okay, we can see that the material has been replaced successfully, which means our logic is fine. If I close the extension panel and open it again, we can see that the extension's data is empty again. However, sometimes we need to save the data. We provide the functionality to save the data using the editor's configuration system. We can check this section in our official documentation. Find Basic in Extending the Editor. Then find Profile. We can see that this section is divided into Editor Settings and Project Settings. Let's look at the main contents. This one is Editor Settings and this one is Project Settings. Default represents the default setting. Message represents the message that needs to be sent when the setting is changed. And Label is the description file. Just copy the code of the editor settings. Paste it in here and change the value of key to mat. Then change the name of the message to change mat and register it in messages. Since we don't need a callback function here, we can just leave it blank. The description file is not needed either. Okay, now the system settings are done. Let's see how we can save and read the data. To save the material, we definitely want this material to be up to date when we close this extension. Again, we define it as an asynchronous function. The material data we save is actually the UUID of the material. The UUID is the value of material in element selector. About how to save, let's take a look at our official documentation. This is the method to read the editor configuration, and this is the method to read the project configuration. But we can't find the method to save. We can look for the API in OpenScene DevTools in the developer menu. We can see that there are getConfig and getProject, which correspond to setConfig and setProject. Let me modify it a little. This is the name of the extension, the key, and the UUID. Okay, the logic to save the data is written. Then when to read the data? Just when the panel is ready. And it's also UUID that is read. The third parameter is its priority. The detail about the priority can be found in the official documentation, so I won't go into details here. After reading the configuration, let's determine if the UUID exists. If it does, assign a value to the material in the element selector. Okay, the code for saving and reading data is done. Let's see the result. Here it is important to know that get last selected type refers to the type we selected last time. I dragged this material over, but it's an asset, so I need to click on this object again over here, because it's a node, and then click Replace to take effect. So my code is actually not very tightly written. Then let's see if the data is saved successfully. Close the extension panel and open it again. Nice, it's a success. Okay, that's it for the extension. If you want to know more about extensions, you can refer to our documentation, or you can give us some requirements. Then we will follow up with more tutorials or articles about extensions. Thank you.